Hi guys, I hope you had a great winter break and welcome back. This is our first video lecture for probability. That's going to cover the basic principle of counting. So I've broken up all the topics we're going to talk about in probability into short little videos for you to review. So today's our first one, basic principle of counting. What is that? It basically says if we have two experiments, and experiment 1 has n outcomes, and experiment 2 has m outcomes, the total number of outcomes is n times m. So we refer to these as experiments, or at least the textbook is. So basically you have two options or two things that can happen. We'll call them two experiments, and we treat it as one big experiment. So we have one little experiment with n outcomes, one other little experiment with m outcomes. Then our big experiment, the whole thing, is got n times m possible outcomes. So let's run through a quick example of this. So suppose you're invited to a dinner. It's a slightly formal occasion, and they've gotten 3 entrees for you to choose from before you arrive, and then they've gotten 2 desserts. We'll say you're going to have to choose a pie, so there's a pie to go with your entree. Of the entrees, you have 3 choices. You could choose beef, you could choose chicken, or you could have fish. And among the pies, let's say that there's a chocolate, there's a cherry pie, apple pie, and banana. So you get 3 choices for entrees, 3 choices for pies. The question is, how many choices are there for dinner? Okay, so dinner is like the big overall experiment, I guess, or the option you have. You want to choose something for dinner, but it's broken up into 2 smaller choices. So you're going to choose an entree, and you're going to pair that with some dessert, some sort of pie. And we want to know how many choices do you have. Well, say you choose beef for an entree. If you choose beef, then with beef you can get chocolate, you can get cherry, apple, or banana. So once you've chosen beef, you still have 4 choices total for a dinner. And this means this gives us four options: beef chocolate, beef cherry, beef apple, beef banana. What about chicken? Well, if you choose chicken, you can do chicken and chocolate, chicken and cherry, chicken and apple, or chicken and banana. So same thing, there's 4 choices. If you pick chicken as the entree, there's 4 possible dinners you can make by choosing any one of the 4 desserts on this side. And obviously the same thing holds for fish. If you choose fish, then you're going to have a total of 4 dinners that you can make. So for each one of the 3 entrees, we can make 4 dinners. And the total is, of course, 3 times 4, which equals 12. And so we end up having a total of 3 times 4 equals 12 options for dinner. So hopefully the picture maybe gives you a little intuition of why this is true. For each one of the 3 entrees, there are 4 desserts to be paired with it, and then it ends up being a total of 3 times 4. So none of the options eliminate each other. Now, for those of you who've taken discrete math, hopefully you can see that we've combined 2 small experiments and get a big experiment. And that gives us a little formula. The number of options for the big experiment is the product of the options for the little experiments. We can generalize this immediately to n cases. So the generalized principle of counting. We have experiments, and let's just call them 1, 2, up to n. So we have experiment 1, experiment 2, experiment 3, and so on. And we'll stop with n experiments. So we have lots of little choices to make. And then let's say the number of outcomes of each of these. We'll just call them A1, A2, A3. And this goes on until we have AN. Then the total number of outcomes So this is one of those cases you should recall that appeals to just basic induction. We take 2 experiments, and the product gives us the total number of outcomes of those 2. So we end up with A1 times A2 experiments for this as 1 experiment. Now if we treat 1 and 2 as 1 experiment, and then we have 3 as a 3rd experiment, the total number of outcomes we can have for 1, 2, and 3 will be, well, we know we already have A1, A2 on this side, and then A3 for this part. So we end up with the product A1, A2, A3. And then just inductively we can get for 4, those are going to be A1 times A2 times A3 times A4 on down to AN. So the total number of outcomes is A1 times A2 times A3 and so on times AN. So referring back to our previous example, if you want to plug in some numbers, you could think of experiment 1 as the entree. So 1 will be the entree. And in that case, A1 was 3. Right? We had 3 choices: chicken, was it beef, chicken, or fish? Experiment 2 can be the dessert, whatever kind of pie you like, and so A2 will be 4. There's 4 choices for dessert. But let's say that they gave you another choice. Say maybe experiment 3 you got an entree also. So maybe you could choose between a soup or a salad or something like that. So maybe they'll give you, say, 5 different entrees to choose from. I'm sorry, not entree, appetizers. So you have the choice among 5 different appetizers. So I mean, fried pickles or whatever your favorite appetizer is, maybe a spinach and artichoke dip. But now you show up, there's 5 appetizers, 4 desserts, 3 entrees, as before. How many different dinners can you make? And by this generalized principle of counting, we take our 3 times 4 that we had before, the 12, and then we multiply that times any of the 5 options we have for appetizers, and get a total of 60 possible dinners. And we'll talk about this further in class, as we will with all the topics in the videos. So that's it for the first one. It's just the basic principle of counting, and then the slight generalization we can do with basic induction. Well, God bless you guys. I'll see you all later.